So let's put this all together by putting basically everything that we've learned. So we've got three rational functions, and we're basically going to go over everything that we've done in this section. So the first thing we usually did is we found the domain. And so for that, we basically looked at the zeros on the bottom. So x squared plus 2x plus 1, when does that equal to 0? Well, if we factored that, we get x plus 1 times x plus 1. And so basically, x can't be equal to negative 1. So our domain is everything to the left of negative 1 and everything to the right of negative 1. So there's our domain. There's part A for that one. Same thing here. When's the denominator equal to 0? Right? So we'll solve the situation there. Again, I can factor this. I believe we get x plus 3, x minus 2. And so x can't be negative 3, and x can't be 2. So domain-wise, we're talking about everything to the left of negative 3. We're talking about everything between negative 3 and 2. And we're talking about everything from 2 to infinity. So there's our domain for that one. And then last but not least, x minus 4. Well, we get that x can't equal to positive 4 here. So negative infinity to 4, union 4 to infinity. Okay, so there is the domain part. So we just basically look, what's the red flag? We account for it. What we also have done, right, is we found potential locations where we have a vertical asymptote or a hole, right? And so to decide that one, we need to figure out, right, do we have matching zeros upstairs and downstairs hole, or do we truly have a vertical asymptote? So right now, if we look at this function, the bottom, we know factors is x plus 1 and x plus 1. The top, I believe when we factor that, let's see, I think this will be a 3 and a 2, a positive and a minus. So we can see that the zeros upstairs, right, don't match with any zeros downstairs, right? Our zeros up here are 3/2 and negative 2. So we truly have vertical asymptote, right, at x equals to negative 1. So there's no holes. This is all vertical asymptote action. So we got B there. Okay, what about the B? Well, we'll talk about that in a moment. We're just concentrating on B. So for part B here again, the top is x minus 2, so the 0 is 2. And then on the bottom, when we factored it, we have x plus 3 and x minus 2. So we can see that there's a common factor. So the 2, we have a true vertical asymptote at negative 3, and then we have a hole at x equals 2. And this function, when we reduce it, is going to behave a lot like 1 over x plus 3, because that's the reduced form of this function as we move along. So there's part B for that one. And then here, the factors upstairs are x minus 2 and x plus 1. And downstairs we have x minus 4. So my zeros up here are 2 and negative 1. They don't match up with my 0 down below. So we have a true vertical asymptote at x equals 4. Alright, so there is part B, vertical asymptote or hole. So we have a vertical asymptote at negative 1. We have a vertical asymptote at 4. But in this one, we have a vertical asymptote at one value, but a hole at the other. Alright, part C, if you have a vertical asymptote, predict the behavior of the graph at this VA. Well, in this case, right, the multiplicity, this is x plus 1 squared. So at negative 1, right, before we graph this, there's negative 1. It's either going in positive infinity in both directions or negative infinity in both directions. So we're expecting to see that when I eventually turn to my technology at a moment. But there's the predicted behavior. At this one, the multiplicity is 1. So when we do graph this function eventually at some time at negative 3, right, I expect the graph to be behaving like so, or maybe in the opposite direction, but it's definitely breaking itself apart. It's going to positive or negative infinity in either direction, so this way or that way, whatever the case might be. And then here we have multiplicity of 1, so the same thing. If we were to graph that vertical asymptote, right, the graph is either doing this and this, or doing this and this. Alright, so there's basically the predicted behavior without turning to technology about the vertical asymptotes. So there's part C. Part D, if there is a hole, can we locate the exact point of this hole? And so in this case, right, the only hole was in this one that's occurring at x equals to 2. So to find that hole, what I basically do, right, is evaluate the function in its simplified form. So when I plug 2 in there, we get 1 over 2 plus 3, we get 1/5. So the hole is located at 2 and 1/5. So again, if we were graphing this, there's 1, so about 2 and 1/5, I would expect to see a hole in the graph at that location. All right, so there is part D. All right, find the horizontal or oblique asymptotes. Well, that had everything to do with the degree. So in this case, the degrees match. So we have a horizontal asymptote, and it's basically the lead coefficient divided by the lead coefficient. So my horizontal asymptote is 2. All right, down here, the degree upstairs is less than the degree downstairs. So our horizontal asymptote is the x-axis, y equals to 0. And then down here, the degree upstairs is larger than the degree downstairs. So we expect an oblique asymptote, right, in that case. All right, so we now did part E, where we have that. Actually, we haven't finished E. We found the horizontal asymptotes. To find the oblique, I performed the division. So we're dividing by x minus 4. So we put a 4 out there. We get a 1, -1, -2. Bring that down. That's a 4. That's a 3. That's a 12. And that's a 10. So basically, we have x plus 3 plus 10 over x minus 4. So there is our oblique asymptote. It's a slant asymptote of y. Oops, I realized I was off the page there. Sorry about that. So we, to find the oblique, we performed the division. I did it synthetically, and so the quotient is our oblique asymptote. So there is part E. We're done with that. Okay. If we do have a horizontal asymptote, can we locate a position where we cross it? Well, let's go ahead and do that. There's only 2 locations where we have a horizontal asymptote. So for this one, we're figuring out when does f of x equal 2. So we get 2x squared plus x minus 6 all over x squared plus 2x plus 1. When's that equal to 2? And if we basically divide by 1, we can cross multiply. So we get 2x squared plus x minus 6 equals x squared 2 times x squared plus 2x plus 1. And so if we start doing the algebra, 2x plus 4x plus 2, if I start subtracting some things around, if I subtract 2x squared, that goes away. If I subtract 4x and add 6, we end up getting negative 3x equals 8. And so divide both sides by negative 3. It looks like we're crossing, right, at negative 8, 3, comma, oops, sorry about that, at 2 and negative 8/3, right? So that looks like where we're crossing the horizontal asymptote at that point. Let me just check my math real quick. So 3x, that's a 4, yep. That's a 2, add 6, we get an 8. Yep, I'm pretty confident. We'll check the stuff in there. How about this one? When does my function equal to 0? So when does x minus 2 all over x squared plus x minus 6 equals to 0? Well, again, if we cross multiply, notice that we're basically, when's the top equal to 0? And so that happens at 2. So this one crosses at 2, 0 again, kind of like the last one. Alrighty, so there's the theory. There's part A, B, C, and D all together. Notice as I do all that algebra, we're going to eventually move in 5.5. I'm getting a lot of good graphical characteristics of my graph, and I can eventually graph this without a calculator. But to do part G, I'm going to go ahead and pause here. I'm almost 10 minutes into this. We'll check our algebra, all right, in another video to finish off this chapter. All right, so hold on real quick. Let me stop this and start another.